Kristine, Tanton, and Anthony Caldwell from UCLA. Please welcome.
Thank you. We're both very excited to be here and to be part of your party, so to speak. We are coming from the academic community, and some of the questions that we will be addressing today are: how do art and architectural historians study monuments that have been lost or changed over time? Our understanding of these monuments relies mainly on fragmentary evidence, such as textual descriptions, drawings, or lithic fragments scattered throughout various warehouses, archives, and museums. Advances in CAD have made it possible to bring these disparate sources together to reconstruct digitally these monumental specters. A current challenge for scholars is how do we annotate or footnote our 3D models and share them across various platforms and native software? Can we include relevant workflow processes, argumentation, and documentation for our reconstructions so that the models themselves have an afterlife beyond the initial scholarly inquiry? Today, Anthony Caldwell and I will discuss how we are developing best practices for historical reconstructions and standards for attaching, viewing, and sharing data for 3D models. We will discuss the various options for annotating the 3D models, such as Open BIM and external databases to document all data and project workflow, while also addressing the unique needs for historical reconstructions to the scholarly community. Our 3D reconstructions are not simply illustrations, but are standalone research objects that can be shared with scholars from a variety of fields. For example, our 3D reconstructions are architecturally viable and adhere to physical and structural rules, allowing for fruitful collaborations with practicing architects, such as yourselves, and structural engineers to test the model's structural integrity. So at the moment, I'm going to pass the microphone on to my colleague, Anthony Caldwell, who will discuss his project of reconstructing the Pharaoh's Lighthouse.
Good afternoon. My name is Anthony Caldwell, and I work at UCLA as a researcher. And in a nutshell, what I do is I reconstruct lost monuments, various lost monuments in different periods. And so I'm going to kind of walk you through what our initial problem was in trying to attach data, and hopefully that'll illustrate some of the techniques and approaches that we've adopted to resolve this. So for those who are not aware of it, or largely aware of it, the Pharaoh's Lighthouse was constructed in about 285 BC. It stood approximately 30 stories high. It remained intact for 1,500 years. It used post and beam construction, and it was a real object. And so what we wanted to do is try and understand how it was built and put together. And so there it is, finished. Ta-da! It's sitting on the site. There's the reconstruction. Part of this reconstruction, if I was to give you the model in some file format, we would see that there's a fully realized model that was made. It has sections going up through it and through the top. You could section the model. You could look at it, zoom into closer. You could do walkthroughs, fly-throughs. You could move around inside the structure in various ways. We were actually even able to export the model and bring it into engineering software to do structural analysis and subject it to seismic forces to see how it would behave and match it against it. So we can do that with the model. So there it is. That's the model. So what is inside that model that you cannot see? Well, there's a timeline of people who told us what the lighthouse looked like in varying types of description throughout the era. There's a lot of visual information about the lighthouse, some of it contradictory, which is some of the problems in reconstructing it. We've got all sorts of things to show us pictograms. We have lots of coins that describe the lighthouse, also in varying stages and points. Also tied to the model is information about technology. Did the Egyptians and the Greeks of 285 BC in Alexandria, Egypt, actually possess the technology required to construct such a building, if it did exist indeed? And there's also information about was there intellectual capital and financial capital to build such a structure. It was allegedly one of the most expensive structures built in the ancient world. In addition to that, we also have information about parallel structures that would have either been built in the image of the lighthouse or perhaps supplied some of the ideas for the lighthouse. Those are also tied in the model. On top of that, we have our own analysis of existing structures. In this case, this is a negative space model of Edfu pylon, temple pylon, and what that revealed to us is how the ancient Greeks and Egyptians felt about three-dimensional space and how they organized it, which is hard to see in other forms. We also looked at other reconstructions that have been done previously. These are two of the more famous constructions that were done at the very beginning of the 20th century. That information is wrapped in there. We also did analysis of our reconstruction against existing ancient buildings that would have been contemporary with the lighthouse to see if our solution to it actually matched up with evidence that we can look at buildings that were built at the same time. And finally, we looked for contemporary structures. As it happens, Philadelphia City Hall is about the right height, the right material, and has a lovely large statue on top. So it's a very nice stand-in. The final piece of the puzzle is the fact that the lighthouse is changing over time. It lasted a very long time. It went through, I believe, 3 tsunamis, several earthquakes, a number of wars, and its form changed. So when we look at the description of the lighthouse, we have to try and filter it and figure out what are we looking at. So all this information ended up in tabular format in a number of databases. It also ended up in something analogous to a digital corkboard where we were able to put up our evidences, draw lines, conclusions, pieces together. And then there's also, running in parallel to that, information about different versions and different ideas we had about, in this case, the top of the lighthouse. There are several different versions and conclusions you could come through looking at the data. All of this is thrown together, and if you want to know how we did it, you read the paper. So, in one word. So, that's great. A few years ago, after the paper was made, I was speaking to a colleague at UCLA, and we said, this kind of sucks, because we have a beautiful three-dimensional model, and we have a lot of data attached to it, and reducing it to something that's a little less than dynamic. So we started to talk about the idea of how could we make the model itself an academic argument and hand it off as a single idea. And in my head, I thought, oh, well, this is great. We could attach data. If we could manage to get our research, photographs of different ideas, sites, images, textual data, links going all over the place, that would be spectacular. So the first thing that occurred to me is that in a number of pieces of software that we use, I use Vectorworks, but I know you can do it in AutoCAD, I know you can do it in Rhino, and you can do it in Bentley, and quite a few others. You can attach data to objects, and this seemed like a very natural place for us to start stacking our information. So we basically started attaching records to all of our model pieces inside. That worked great. We were able, in this case, this is an illustration, the colored boxes represent potential footprints of the lighthouse, and we were able to tie data as to, well, where does that come from? Where did you get that idea? And why did you go with one over the other? This was really helpful in tying data together, but then we ran into a new problem, which was, okay, I've stacked the model with data, and I hand it to somebody else. Well, how do they know what objects have data, and how do they know what kind of data is attached to those objects? There are various ways to pull it out, but it's not particularly obvious inside of it. So what we decided to do, and again, you can do this in a variety of different pieces of software. We're using Vectorworks in order to do it, is we were able to tie different tables to the object. Multiple tables to pieces inside the model is actually very useful. There were a number of rather fruitless discussions with colleagues about, well, if we're going to attach data to model pieces, what should those fields and tables look like? And everyone, various specialists, had various ideas about what they wanted. What we finally decided was to just create a simple index table, put it at the top level, that everyone agreed what that information would be in the index table, and then every specialist could add their own table. That worked great, and that got us to the next part of the question. How do you get it out? Again, you can do a simple report. It's available in a lot of software, and it allows us to query that one table, which acts as an index. We were able to pull that index information out, and you could know what was in the model. So the next problem was somebody said, yeah, well, we'd like to share these models now with researchers who aren't in our own group. We'd like to exchange them back and forth. and we would like to annotate them and have our colleagues annotate them and bring them back to us and make it more of a living model. This sounded a little bit familiar to me, so I began to look at the idea of how we could co-opt BIM perhaps for this process. So the spinal diagram that I have is basically what we ended up doing. So inside the model, there's a record format in the upper left of the illustration here, which is tied to the pieces of information, or model pieces that we want to attach information to. That is actually going through a database driver that stores the data externally on a MySQL database. Why did we do that? We do that because we want the model itself to be annotated in the field, and we wanted a central place to store the information and be able to move it around. So we were able, through ODBC, which is a database driver, to attach it to MySQL. We could attach it to a lot of different things. Going the other direction, we used a process where we can actually synchronize the record format in Vectorworks with an IFC record, a custom property. And so we created the custom property, and we were able to synchronize the two records. The reason we did this is so that we could export it as an IFC project or model. And in this case, the idea was that we could hand that IFC model to someone who may not be using Vectorworks, but can get their hands on an IFC viewer or a number of other, or import it into another piece of software that recognizes it. And that would allow them to see our data sets attached to it and basically annotate and return it to us. So I'm going to hand this back to Kristine. This is kind of where I started with the process, and then somehow suckered her into continuing on.
So for the, I'm a specialist in medieval art and architecture, just to put that out there. My research follows two veins. I focus on the dynamic relationships among sculpture, architecture, and ritual activity in the Middle Ages, and through the reconstruction work I've been doing, I've become more and more interested in the material processes of medieval art and architecture. And to interrogate these areas more fruitfully, I integrate traditional research methods with new media technology, which allows me to perform quantitative as well as qualitative analysis. This is sort of the direction the field has been going in. For the past 3 years, I have been the project manager on the research and pedagogical project Paris Past and Present at UCLA. Meredith Cohen, the professor of medieval art and architecture at UCLA, is the PI. And it's a collaborative project which aims to digitally reconstruct with archaeological precision the lost monuments of Gothic Paris, which dates between 1000 and 1500. By integrating the fragmented evidence remaining from these buildings into coherent virtual models, this project is significantly expanding the limited corpus of extant monuments and reshaping our knowledge of medieval architecture. The three-dimensional models provide a way to study lost monuments or lost iterations of monuments, and thus allow us to produce new knowledge and new ways of knowing by mining aesthetic and cultural practices that were not previously visible. Since 2014, our team has created about a dozen buildings from a total of some 55, first constructed during the long 13th century of Saint Louis, a period which only parts of 5 buildings are still extant. These are the years when Paris was the leading cultural and political capital of Europe, boasting not only the largest population and strongest monarchy on the continent, but also an architecture that came to define its urban identity with a symbolic power resonating far beyond the city's boundaries. Many of these monuments were destroyed in the French Revolution or its aftermath, in many cases because of this profound history. And a plethora of evidence concerning them remains in the form of archaeology, stone fragments, graphic images, such as engravings or elevation or plans, and written descriptions. While the most beautiful pieces from these buildings are displayed in museums, much of this material is unknown as it is hidden in suburban warehouses, I've dug for many of them, or in the depths of the archives. When gathered together through research, this information is still challenging to reconstruct in the mind's eye, making any discussion of these subjects highly subjective and speculative. Our project makes these abstract resources useful by weaving them together as comprehensible 3D units. And here we have our reconstruction of the Lady Chapel of the Abbey of Saint-Germain-des-Prés in Paris. It was built by Pierre de Montreuil, the architect of 13th century France. And you can see just some of our images from that. By integrating the fragmented evidence remaining from these buildings into coherent virtual models, we can expand the limited corpus of extant monuments and reshape our knowledge of medieval architecture. A significant component of our work has been developing a method of reconstruction and display that clarifies the difference between original evidence, extrapolation based on the evidence, and sheer hypothesis, which has proven to be more challenging than expected. Working with Anthony and other scholars involved in 3D reconstructions, we're trying to develop standards for attaching this information to the models. And at the moment, here's a data model on which I'm currently working. As you can see, I have identified 7 key, because it's hard to look up here, 7 key evidence types for historical reconstructions. There's textual, lithic, archaeological, comparative, and my favorite, hypothetical extrapolation. That's sort of the sheer hypothesis part. And I have identified these as annotation types, and any part of the reconstruction would include any combination of these. We are using Vectorworks in the project at the moment, and the advantage of this software is that our models are complete and adhere to construction principles, as I've mentioned, and they allow for structural testing. And in fact, we have done several 3D prints of it, and we have passed the model on to structural engineers to run some tests. As you know, Gothic architecture is very sculptural and employs many curves, and each object is custom made. We cannot use any of the parametric objects that are standard in modern architectural software, which has made some of the BIM options problematic. In order to integrate all resources for the model, including the rich media, sound clips, images, video, etc., I have found that an external database has been our, this is just another shot of a nice vault, an external database has been our best solution. At first, we thought we could use the data record format in Vectorworks, as Anthony did, and we found that displaying the table structure was problematic. It required a lot of onerous formatting, which not all scholars were willing to go through. The other issue was it was difficult to view large text fields, and furthermore, the Vectorworks record formats do not support the rich media, which is a large part of our resources. We have attempted to use IFC, but because our models are not constructed with parametric objects, it's difficult to display. As you can see in this, there we go, in this IFC viewer, where our rose window, the geometry has completely been lost. A rose window that looks like this would just not pass muster, nor would it pass any medieval building code that we could use. As you all know, the IFC data model describes building and construction industry data, and this is standard practice for you all, and because it's a platform neutral and an open file format, it seems logical to integrate it into our annotation. However, there are no IFC standards for pointed arches or ribbed vaults, and if anyone knows of them, please find me after, because that would be great. Scholars, and I'm thinking specifically of several colleagues in Europe, have tried to develop HBIM, historical BIM, but there's no established standard, and among scholars there seems to be a widespread misconception that BIM means 3D design, which clouds any fruitful discussion about annotating models. In my mind, it's metadata, and they keep on talking about the model itself. We may be able to create an IFC proxy field, which Anthony and I have been working on for our resources, but it would in no way provide a means to annotate fully the model. And we are currently using the IFC proxy field as a place to capture an abstract for the project, as well as keywords and metadata as a type of mark record, so that we can pass the model along to a library or an archive so that it could go into a digital repository. Our current solution is to assign a unique part ID into a data record within the model, and that would hook into an external database. And I have here, this is just a demo. It is in no way complete and includes all the things I would want in my database, like password protection, et cetera. But it does allow us to fully inhabit as many fields and annotation types and run queries. And in addition, we are able to pull out and send a URL to colleagues to show all of the annotation types attached to any particular part of the model, indeed in the model itself. Also, as the project grows, we're able to track and run queries based on which team member worked on which part of each model, as well as to really document workflow. So moving forward, we really are trying to figure out how to also know when we hand it off, how someone can open the model and know what's going on. We've all opened someone's file and find everything that they did wrong that isn't the way that you would work. And one thing that I've worked up is just a simple legend that would be available in top plan view, noting the various annotation types or evidence that's attached to a particular part and attaching that to the model itself in varying views that you can turn on and off. It would be on its own class or layer. So at least someone who's not familiar with the model would be able to instantly open it up and know what your argumentation process was. So this is very much a work in progress. The digital modeling working group that Anthony, myself, and Deidre Whitmore of the Cudson Institute at UCLA have established are working together to set something up. We've had a workshop with people from the Getty and other scholars at UCLA, and academia is just really starting to address these standards. Now, something that Anthony and I have tried to bring to our project, since we both have previous studio experience, Anthony in architecture, myself in graphic design, is to integrate studio practices into our projects so that we can basically allow for a rotation of team members as well as a way to hand off projects so that people can follow them and to capture the project management workflow. So that is where we are at the moment, and we would really look forward to hearing how you all are solving some of these issues and any suggestions you may have for us. So thank you very much.
So any questions?
Yes, these models are, is there a way to get them in AutoCAD as the DWG?
Yes, they can be exported into a variety of different formats that can be read by other software packages.
Point clouds, or
Yes.
they are?
Well, no, we can export them as a point cloud. And in some instances where we have used, for example, in the Lady Chapel on the left, there is a portal there that is actually in a museum, so that's photogrammetry that has been inserted into the model. But yeah, these models can be shared amongst various software and as well as platforms.
Are you focused on European pieces at the moment, and any plans to extend it to other world heritages that might be either version disappearing or gone?
Not personally, but these types of projects allow other scholars to create a sort of network. So if you have a pre-Columbian specialist, or for example, people that are working on Palmyra. So these types of projects actually have a lot in common with cultural heritage projects. So I think setting standards so that these projects can be sustained and talk to each other are helpful. I just happen to be, I'm a medieval European specialist. But what we do can be applied to other disciplines, and definitely it is being done by scholars across the globe as well as time periods.
Oh, and the projects I'm starting to work on now actually involve downtown LA and the historic theater core. So we're starting to take what we've learned here, and what we couldn't do with these projects is actually start from day one attaching the data, because these evolved and then we put the data on backwards. So this time we can actually start with what we've learned and apply the data going forward.
Have you been using 3D scanning technology to influence the music modeling?
Not for the Lady Chapel and much of the Paris material because there really isn't enough to laser scan. I am currently working on a reconstruction of the East End at a Romanesque basilica at Vézelay, and I am working with another scholar to arrange to laser scan the part of the building that is from the 12th century, whereas the East End is 13th century, and I want to reconceive or recreate the 12th century East End. So in that instance, when you have parts of a building, the laser scanning is very useful. Andrew Talon at Vassar is doing a lot of laser scanning of Gothic cathedrals and studying those. So yes, that's something that going forward, I'm going to be using in my next project.
Do you find that they would capture the level of detail, though, in a lot of these models that you're going for?
The display would be slightly different, but the laser scans coupled with archaeological reports have been highly accurate. It's kind of been amazing what you can do. Yes?
This work is really exciting. I'm wondering, given the evolution of a building or of a city and the number of reconstructions that occur over time, is it your intention to include as many of those kind of phases along the way as possible?
Yes.
And are you finding that the software that you're using is adept at kind of building in that phasing?
It's a bit challenging. Some of the technology is not there in terms of how we can bring that all together. Mary Cohen is very interested in creating some sort of hub and an interactive map for Paris, for example, but that is something that we are anticipating will be able to come together. It's just we haven't been able to solve all the problems, but that's the dream. And enough people are doing it where I think we're going to see great advances very quickly. Thank you. I think we need to move on to our next one. Thank you very much.